So this FRQ is from 2017, number 3. A grocery store purchases melons from 2 distributors, J and K. Blah, blah, blah. The distribution of diameters of the melon from J is approximately normal with a mean of 133 and a standard deviation of 5. For melons selected at random from distributor J, what is the probability the melon will have a diameter greater than 137? So here they told me that those melons are normally distributed with this mean and this standard deviation. And then I wrote my probability statement equals my answer. They use z-scores, but we're too cool for z-scores. We use our fancy calculator instead of the old school table. Part A is essentially correct if you have the following 3 components: normality and parameters. This is the most recent scoring guideline we've looked at. This should be the one that you trust or that you base your work off of the most. Indicates the use of normal or approximately normal distribution, clearly identifies the correct parameter values. That's what this does. This is a standard notation that gets me credit for the first component. Part 2 is boundary and direction. So I indicate my boundary is 137 and that I'm doing greater than that. So that indicates my boundary and direction in the most efficient way possible with the correct answer. Let's just double check that's the correct answer. Yes, it is. So you need all 3 of those to get essentially correct. They have a bunch of notes down here. So part C is the correct answer. Component 3 is the correct answer based on parts 1 and 2. So if you accidentally did less than, then you can still get a partially correct if this answer is consistent with less than. Or if you somehow wrote down 143, or I don't know. If you wrote down the wrong number here, you can also get partially correct if your answer is consistent. Use of a value other than 137 does not satisfy the second component. I don't know why it would. Okay, I think that covers everything. You can read those if you need to in more detail, but I don't think it's necessary. Part B, distributor K, blah, 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 probabilities 0.8413 that a melon from distributor K will have a diameter greater than 137. For all the melons at the grocery store, 70% of the melons are provided by J and the rest are provided by K. For melons selected at random from the grocery store, what is the probability that the melon will have a diameter greater than 137? So there are 2 ways to do it. You can do a tree diagram, which is what I do. That's what I highly recommend. I love tree diagrams. So it splits either your melon came from J or it came from K. And then after that, the diameter is either less than 137 or greater than 137. For J, I got the number from up here. For K, I got the number from right here. Remember, to get this number, it's just 1 minus that number and 1 minus that number to get that one. And then you multiply your branches. And then I want the probability that the melon will have a diameter greater than 137, so I add the 2 that are greater than 137. So they got, let's just double check, 0.4007 or 0.40072, both are correct. Essentially correct if the probability is computed correctly and work is shown that shows correct numerical values using a formula and results from a tree diagram or some other appropriate method. Note, if used, the multiplication is implied. If a tree diagram is used, the multiplication is implied, but the addition must be indicated. If not used, the multiplication and addition must be indicated. So because I did a tree diagram, the multiplication of the branches is implied. So all I had to show was the adding. But if you didn't show a tree diagram, you had to show the multiplication to get this number and this number. So you would have had to write 0.7 times 0.2119 plus 0.3 times 0.8413 equals 0.4007. So you would have had to show those steps. If you accidentally switch these two numbers, but then everything is correct going after that, you would got a partially correct. You also could have set up a table instead of a tree diagram if you wanted to. If you set up a tree diagram, if you had a good process, but then you somehow made a small mistake, you got partially correct. Part C, given that a melon selected at random from the grocery store has a diameter greater than 137, so it's a given, this is a conditional probability, so we'll do the and over the given. What is the probability the melon will be from distributor J? So I want the and on top, J and greater than 137 on top. So J and greater than 137. No. Oh, I must have been tired. And J and greater than 137. This number should have been 0.14833. The given is that we have a diameter greater than 137. So you divide those and you would get 0.3701. Yeah, whoops. Yeah, this is why I shouldn't do homework late at night, huh? Essentially correct, the probability is computed correctly, and work shown that illuminates how the probability was found. Partially correct if the response provides a correct strategy for finding the probability for a dependent variable, such as the appropriate formula. So it's a good thing I wrote the formula this time. I don't always write that, but that should get me partially correct. But if you got the correct answer without enough indication of the work, that's a partially correct. Yep, this is a P here. So sad. By the way, part C earns an E if correct answer follows from incorrect values used in part A and or part B. So all of this is error carried forward. If you made a mistake on this one and you carried that error forward, you would have lost points on part A, but B and C would have been completely correct as long as the answers you got are possible. Same thing on part C. If you made a mistake on part B, but then your answer is consistent with part B for part C, 100% correct, as long as the answer you got is reasonable, meaning it's between 0 and 1. So if you got above 1 or less than 0, it was not essentially correct. But other than that, it would have been essentially correct for the parts going forward. So that's an error carried forward. You make the mistake once, you don't get penalized for it every time. In any part, unsupported answers are scored as an I. So that means if you didn't show any work, if you just wrote the 3 numbers, you would have gotten 0 out of 4, even if all 3 numbers were correct. Now, if you showed some work, it just wasn't good work, you would have gotten partially correct. But if you did not show any work at all, it looks like they gave you an I on all parts. So read this, it's the same as usual. This is a 3 out of 4. I really need to be more careful, huh? All right, good luck. I hope you feel better about probability. I know this is a unit people struggle with the most. Email your teacher or come to office hours if you have any questions. And if you want any additional practice, remember you can go back and do the supplemental packets again, or even the homework packets again from units 4 and 5. Those are all on your Canvas module, original Canvas modules.